Welcome back to Otomo Tutorials, where in this video we will be discussing the formation of simple ions. And I felt like it would be good to start this video by building on something that we've already covered. And this page that we're on is actually from the first video of topic 1, where we looked at the atomic structure. And we looked at the relative charges of the subatomic particles, and we said that atoms are neutral and so must contain equal numbers of protons and electrons. This was because protons are positively charged and electrons are negatively charged. And so having equal numbers balances out the charge to the overall charge, that is, to 0. I also said that when there is an imbalance of these particles, ions form. Now, ions are, as the specification says, an atom or a group of atoms with a positive or a negative charge. Now, we all know that the number of protons doesn't change for a particular element without changing the entire element itself. So ions are formed when electrons are lost or gained. Now, if you lose one electron, you have one more positively charged proton than you do negatively charged electron. And so the overall charge is positive. So positive ions form when you lose electrons. When an atom gains an electron, you have more electrons than protons, so the overall charge becomes negative. Negatively charged ions therefore form when atoms gain electrons. Positively charged ions can also be referred to as cations, while negatively charged ions can be referred to as anions. And so that's how simple ions form. And by the way, a simple ion A simple ion just refers to an ion which is formed from a single atom. But ionic bonds, which we're going to look at in more detail, as well as the structure of ionic compounds, ionic bonds are formed when electrons transfer from one atom to another. And we can illustrate this through these things called dot and cross diagrams, which we have here. So if we look at an atom of lithium, which is here, lithium has 1 electron on its outer shell, and this atom here, which is fluorine, has 7 electrons on its outer shell. So what happens in forming an ionic attraction is that the electron from the outer shell of lithium is transferred to fluorine. And this does two things. The lithium atom has lost its outer electron, and because it's lost an electron, a singly positively charged lithium ion is formed. But the fluoride has gained this electron, and so a singly charged negative fluoride ion is formed. So we have two ions of opposite charge now, and these two ions attract each other, and this is what we know as an ionic bond. Now you'll hopefully have noticed that after the electron transfer, both ions have full outer shells. And this is something which makes ions stable. In general, a particle, whether it be an atom or an ion, is much more stable with a full outer shell. And I actually briefly mentioned this when talking about the very stable group 0 elements, which all have full outer shells. So when looking at simple ions, ions forming from single atoms, we can look at that element and we can see where it is in the periodic table, and this can tell us what charge it will form when it becomes an ion. So the elements that most commonly form ions are ones in groups 1, 2, 6, and 7. Metal elements in group 1 form singly charged positive ions. This is because they have 1 electron on their outer shell. They lose this and form a +1 ion. Group 2 elements have 2 electrons in their outer shell. Now remember, an ion with a full outer shell is quite stable. So by losing 2 electrons, you would have a 2+ positive charge on your ion as well as a full outer shell, because the electron shell underneath is full. Non-metal group 6 and 7 elements tend to form negative ions by gaining electrons. Group 6 elements have 6 electrons on their outer shell. And so instead of losing these 6 electrons and gaining a full outer shell that way, what happens is that they gain 2 electrons to complete a full outer shell of 8. Gaining 2 electrons, of course, means that the ion has a charge of 2-. It's very similar for group 7 elements, except they have 7 electrons on their outer shell, and so only need to gain 1 electron to get a full shell of 8. And this means that they form 1- ions. So you'll hopefully remember that we had a method to work out the number of protons, neutrons, and electrons for atoms, given certain pieces of information. We're going to do the same thing here, but with simple ions. So you would need a few pieces of information in order to do this as well. You would firstly need to know the charge on the ion, and you would also need to know the mass number and the atomic number of the atom from which this ion is formed. Now the first example is the 1+ charged sodium ion. And we know the number of protons is the same as the atomic number, and this is 11, and this is a number which doesn't change. We also follow the same method for working out the number of neutrons, which is to take away the atomic number from the mass number. In this case, we have a mass number of 23 minus an atomic number of 11. 23 minus 11 is 12. Now, when working out the number of electrons, what we do is we take the atomic number, which is 11, and then we look at the charge. If that charge is positive, then we take the charge number, so in this case 1, away from the atomic number. If the charge is negative, then we add this number to the atomic number. In this case, the charge is positive, so we will take 1 away from 11, which is obviously 10. So this ion has 10 electrons, which makes complete sense. We've got 11 positive subatomic particles and 10 negative subatomic particles. So we have an imbalance of these charged particles within the atom, resulting in an overall positive charge. Now let's apply this to the other example, the oxide ion. We have an atomic number of 8, so we've got 8 protons. The number of neutrons is the mass number minus the atomic number, that is 16 minus 8, which is 8. Now for the electrons, the ion has a charge, 2- charge. So this time we add 2 onto the atomic number. So 8 plus 2 is 10. And this ion has 10 electrons. So this is the guide that you can use to work out how many of each subatomic particle we have in a simple ion. When working out the number of protons and the number of neutrons, the method doesn't change from when we were looking at atoms. The only thing it changes is how we get the number of electrons. So you can hopefully see how this works. If an ion has a positive charge, we take it away from the atomic number. If an ion has a negative charge, we would be, in this formula, effectively taking away a negative number, and 2 negative signs together like that makes a positive, and we would end up adding this number if the ion was negative, and that's how it works.